What's up, Algebra 2 crew? Here we are with the Standard 1B Summative Review. Okay, we're going to do the front half in class today. You'll have the second half to do on your own, and then we'll trade it in for your test tomorrow. Okay, we got the area of a parking lot is 100 square meters. A car takes 5 and a bus takes 10. So I'm going to call cars X and bus Y. More than 12 vehicles, so not 12, but more than 12, need to be parked to cover the cost of the parking lot attendant. Let C represent number of cars and B represent number of buses. I'm going to go X and Y. Okay, write a system of inequalities. Alright, so don't forget your real world ones right off the bat. We need x greater than or equal to 0 and y greater than or equal to 0. Okay, now let's do a square area part. Okay, we got 5x plus 10y needs to be less than or equal to 100, and a total cars we got x plus y more than, so just a greater than here, greater than 12. Okay, so we got a decision to make here with our real world ones. Okay, x is greater than or equal to 0, y greater than or equal to 0. Do you just want to go right here on the axes, right, quadrant 1, or do you want to zoom out and redraw your axes right here and then just call these like 10, 20, 10, 20? Up to you. We've done it both ways. Let's see. Let's just roll with the small screen today. But if you want to zoom out and redraw your lines there, and then just call these 0, 0, 0, 10, 0, 20, 10, 0, 20, 0, you could do that. Okay, I think I did that on my answer key, so that's what it would look like. I'm going to redraw it way out here. 0, 0, 10, 20, 10, 20. Okay, so you have that for the answer key, but for in class, we'll maybe go this way. Okay? So we are x is greater than or equal to 0, which is going to be on the y line. And we'll have y is greater than or equal to 0, which means that is the x line. Okay? And right now we are in quadrant 1. Next we have probably the toughest line to work with, 5x plus 10y less than or equal to 100. Okay, we're going to subtract the 5x over. And divide by 10. So we'll have negative a half x plus 10. And then this one's going to be 12. So do you want to go with, let's go by 2's. We'll go by 2's. 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. Okay, so we have plus 10. And because we're doing the same scale each way, you can still do down 1 box over 2. You don't have to worry about going down 1, out 2, down 1, out 2. Okay? We can still do down 1 box, out 2 boxes because we have the same scale on each side of the box. So down 1, out 2, down 1, out 2, And that's going to be way out here at 20. And that is less than or equal to, so solid line. And underneath. Alright, our purple one, probably the easiest one to do, just subtract the x over. Negative x plus 12. So we're going to start up here at 12. And again, you don't have to worry about going down 1 over 1 and being like in the middle of a box. Okay, because the boxes are the same dimensions, you got 2 out, 2 up, we can still just do down 1 box over 1. So down 1 over 1, down 1 over 1. There's our point of intersection. Down 1 over 1. Okay, and this one is a dotted line, greater than, so it's going to be a dotted line. Okay, and greater than is going to be above. Okay, and where are we? Have all the shading. Green, purple, and pink. It's going to be right here. We're above the purple one, but below the green. And we crossed at 4, 8. So what are your intersection points? We have 4, 8, 12, 0, and 20, 0, way out there. Good thing we did go by 2s. Okay, and circle those that count in the solutions. Okay, so we talked about dotted lines versus solid lines. There are points on the dotted line. The actual line is the equal to part. Okay, so we had x plus y greater than 12. So the actual line, like the dots on the line, like 2, 10, add up to 12. But they're not greater than 12. So these points on the line actually don't count. Okay, they just show where the border, where the line would be, and then all the points above that work. So the points on the line don't count. So when you have a dotted line, any point that's part of that dotted line is not going to count. So 12, 0, even though it crosses a solid line, it's also made by a dotted line, so that one doesn't count. Our nice intersection point up here, 4, 8, doesn't count. Even though it's part of the green solid line, it's also the purple dotted line. No good. So the only corner point that counts is 20, 0. Okay? Now we have lots of other points that are inside here that would work, but the only corner point that's going to work for us is 20, 0. Alright. Turn the page. Well, before we turn the page, here's what it looks like if you zoomed out. Okay? Zoomed out. Use the whole thing as quadrant 1. Kind of relabeled it. Alright? So that's what that would look like there. In case you zoomed out. Or what I call zoomed out. Whatever works for you. Okay? Next. I like these problems the best. I think these are fun. Okay, farmer's trying to determine how many acres of soybeans, X, and corn, Y, he should plant on the farm. If he profits 400 per acre of soybean and 325 per acre of corn, write a profit function. P equals 400X plus 325Y. Pretty easy one, right? Right off of the reading. 400 per acre X of soybeans and 325 per acre of corn Y. Okay, and then they give you the graph this time, and you need to determine the number of acres to maximize profit. Now we talked about that when you're trying to maximize and minimize stuff, the nice part is about that is it always, maximums and minimums, will always happen at these corners. Okay, so we need to test these three corners. We got 0, comma, looks like we're going by 25s on these very faint grid lines. This is going to be 0, comma, 320 or 350. 0, comma, 350. This one's 300, comma, 0. And then we have 400, comma, 150. Those are our 3 points, our 3 corners, and they're all solid lines, thankfully, so all the points count. That'd be really mean if they gave you a dotted line on this one. Or kind of nice, because then you'd only have 1 point. Okay, and then we're going to test these 3 points in our profit statement equation. And you need to show me that work. And pick the one that makes us the most money. Okay, so let's just go from left to right. 0, comma, 350. So that's going to be 400 times 0 plus 325 times 350. And we can type that into the calculator. And we should be getting 113,000. Oh, now I'm going to have to type it in again because I can't read that. Is it 750? 400 times 0 plus 325 times 350. Probably don't need to do the 400 times 0 part. 750. There it is. Okay, there's your first one. Now let's go for this point. Now that's x, so that's going to go with the first spot. That's 400 times 300 plus 325 times 0. And that should be 120,000. 4 times 3 is 12, and we have 1, 2, 3, 4 zeros to put behind it. And last but not least here we have 400, comma, 150. So we have 400 times 400 plus 325 times 150. And this one's going to put us over the top. 208,750. This one's the winner. Okay, now don't be lazy and just circle this. Put this back up here on the answer line. What's going to maximize it for us? 400 acres of soybeans, 150 acres of corn, and that's going to get us $208,750. Ta-da! All right, folks, you got the next set of problems there on your own, and we have to have all that done for the test. Thanks for watching, and good luck.